Hello again, YouTube. This is Carlos once again with CHS Electronics. I'm here this afternoon or this evening to give an update on this project with the DC or programmable DC load. I made some changes to the code. I actually can track the current better than I did with the previous code. Although I still can't seem to get rid of that 0.01, but that I already know what that is. That's because the op amp that's controlling the output transistors or the current sink transistors are not being turned off all the way. They have 3.6 volts at the gate at the moment. But anyways, wanted to show you how it tracks better now. So right now I'm in keypad mode. Let me get out of that. I'm in potentiometer mode now. So I can turn it up and I can set it to 183, 184. My voltage is at 183, 84 that I set it to. And my multimeter reads practically the same thing. Now I'm using one of these linear power supplies to power this unit. As you can see, I took out, well, I didn't take out, I left it in there, but I disconnected that switch mode power supply and I connected directly to one of these linear power supplies so I can have a better or less noise power on the supply rails. As I continue to, let me see if I can catch them both. If I continue to increase it, it should follow it fairly close. Now there's still some discrepancies when it comes to the current. It may be off 1 or 2 here and there, but I've made some changes in it that I can actually go past my my 10 amp limit that I had set previously. There goes my fan, and as you can see on the voltage down here, that's running off of this power supply, I believe, and it says it's running at 15 volts, but if I turn it down, it goes up to 22 and some change. Well, there's something wrong with that power supply. I believe it's this one. So obviously it's not regulating the current as well as it should, because it should be putting out 12 volts instead of 22.6. But it can still supply the amount of current I need to test this device here. So my meter only goes up to 10 amps maximum, but as you can see, it tracks very closely, and my meter's beeping at 10 amps. But I can go further than that. I just don't have enough load or enough current available from each one of these single. But I think if I put them in parallel and find some big enough diodes, I think I can put two and two together, or put two together to make a 20 amp supply at 12 volts. Anyways, this is what it's doing. Now I can go into, let me turn this down so you can see temperatures at 55 on one of my fits and 50 degrees on the other. So yeah, that's going to get pretty warm. So now if I go to keypad mode, I can type in 5 amps, press enter, and my supply read, or my load reads 4.99, and my meter will read 5 on the dot. Set it to 5, you get 5. That's excellent. So that's all done in code, and that was a little bit of calibration I do. And I ended up using, well, the difference code was, I didn't just read the analog pin at one point in time. I read it multiple times repeatedly, and then I added those values together, and then I divided by 16, which ended up giving me a much better resolution. So with that, I was able to actually get some better displays, and I was able to calibrate it much better. So let's see if my fan still stutters or sputters, because it shouldn't once it reaches 30 degrees or so. But in the meantime, let me get the computer ready. Let me get that set up so that I can show you the difference in the code that I made. So let me pull this up here. There it is. And I'll go to my DC load. And can't remember the technique that I remember that is called, but I basically I read the temperature. I read the analog pin 256 times. Well, in this case, actually, it's only 16 times. Up, there went the fan, and it didn't sputter, so that's good. Let's see if we can do that again. Let me put it back on key mode here. I mean on potentiometer mode. Turn it back up. See if we get some 5.73, 5.71. Close enough. So what I do is I get 15 samples right here, and I add all these 15 samples, and then I divide it by 16, and then I do some manipulation with math, and I get to my values. I believe this is called well, essentially by doing that, I am increasing the number of effective bits that I can use. So even though I'm limited in hardware by a 12-bit analog to digital converter, I am actually increasing it by 2 bits. So by oversampling, that's what it's called. By oversampling 15 times, I can increase the number of effective bits by 2. So it allows me for greater control and better results. So there you go. Let me turn this back down. Oh, let it go too high. Now it's at 39. So let me talk a little bit more about the schematic. So I've told you guys I already have my 2 DACs. On the previous versions, I only had one DAC running 2. Oh no, I had 2. I'm sorry. Changed the fan control, and I introduced an actual 5-volt precision voltage reference. This is all on the digital side, and on the analog side, I changed the values of some of these capacitors and reduced the values of some of these resistors on the voltage follower amplifiers. And on the hardware side, let me show you what I did on the hardware. See, the fan didn't stutter again, didn't sputter. Let me turn it off so I can play it safe here before I burn something up. Let me turn it sideways or stand it right up so you can see inside. Now on the inside, you can see I added a second resistor here and a second resistor here. Now I know there's not they're not heat sinked, but they don't get as warm as I thought they would have. But basically I just stuck the iron in there, stuck the pin in there, and the component in there, and I soldered them as best I could in parallel with the existing current sense resistors. So effectively I have 4 1 ohm resistors, but two are in parallel, so it brings my totals down to half an ohm, so I can actually drive those FET transistors a lot harder now, and therefore increasing my current capability. That's the meter. Well, anyways, I just thought I'd give you guys a quick update on this project, and just to let y'all know that I haven't forgotten about it, or I haven't dismissed it. Now, as far as the voltage reading is concerned, let me get that to work. Once I turn on the power supply, maybe we can get some voltage reading. But I still have the issue with the fan. So let me set this to around 5 volts. And as soon as the fan kicks in, you'll see that the voltage will still drop 1,200 millivolts. And after doing some more research, I realized that the fan itself, the reason it's causing that problem, there it goes, is because it generates a lot of noise on the ground planes, and therefore I have to isolate the ground from the fan, and in fact the power as well, from the rest of the circuit. So here I have my digital power and my analog power tied in together at this location along with the grounds, but I don't have the fans isolated like this as well. So effectively I'm gonna have to change that on this third revision, or revision 3 should I say, but I don't know, I may end up changing it on revision 4 if I test it and it ends up working as it should. Anyways, thanks for sticking around, and I hope you enjoyed this video, and like always, don't forget to like, comment, and subscribe. Thank you for watching.